students will find real numbers, will be able to compare and order real numbers. Students will be able to find the opposite and absolute value of a number, and students will be able to identify properties of real numbers. So the classifications of real numbers. Natural numbers, like 1, 2, 3, 4, are no counting. Whole numbers, which include 0, 1, 2, 3, 4, etc., are all the natural numbers and 0. Integers, like -3, -2, -1, 0, 1, 2, and 3, are natural numbers, which are positive integers, their opposites, which are negative integers, and 0. Rational numbers, like -2/3, 0, 3/10, -1.45, can be written as fractions. The word ratio means fractions, so this is a great way to remember. Rational numbers include terminating decimals and repeating decimals, which means decimals that end or decimals that go on forever but with a pattern. Irrational numbers, like the square root of 2, the square root of 7, pi, or decimals that go on forever, cannot be written as fractions. They include decimals that do not terminate or repeat, and they also include when you try to take the square root of a non-perfect square. Diagram shows the classifications of real numbers and how they're related to each other. Notice how numbers are also whole numbers, and how all whole numbers are integers, how all integers are rational numbers. If a number is rational, it cannot be irrational, and both rational numbers and irrational numbers make up the real number system. There are 2 mistakes on this screen. Pause it, see if you can find the 2 mistakes. Is that negative reduces to negative? It should be category. That would be the most specific classification for -10/5. The other mistake is that 5 should be with the natural numbers. Pause the screen and try putting the numbers above in the appropriate classification area. You can start the slideshow again once your answer's on paper. Is this what you got? This slide asks you to label the following numbers with the appropriate classifications. It is multiple, choose all that apply. Pause the screen until you have all your answers down, and then you can start again to compare and see if you got the right answers. 1 is a natural because it's a counting number, and all natural numbers are whole numbers, integers, and rational numbers. Number 2, 4.83, can be written as a fraction, and therefore it's rational. Number 3, -16 is an integer, and all integers are rational numbers. Number 4, the square root of 10, is the square root of a non-perfect square, and therefore will give us an irrational answer. Number 5, -17/31 is a fraction, and therefore it is rational. Number 6, the square root of 16, when simplified, is 4, which is a natural number. So A, B, C, and D are the correct answers. Is E false? If it is false, give a counterexample, which is an example that proves your point. Pause the screen until you have, and then you may resume. Number 1, All whole numbers are integers. This is true. Number 2, all integers are whole numbers. This is false. For example, -7 is an integer that is not a whole number. Number 3, no fractions are whole numbers. This is false. Think of 10/5, which equals 2. Number 4, all whole numbers are rational numbers. This is true. Order the following numbers from least to greatest, then graph on a number line. Take a moment to do this on your paper. Press play once you are finished. -1 goes right on -1. -1.6 should be just to the left of -1.5. 2/5, which is 0.4, would be just to the left of 0.5, or 1/2. -1.25 should be exactly halfway between -1 and -1.5. -3/8 should be just to the right of -1/2, because -4/8 is -1, very close. Following numbers with less than, greater than, or equal to. Again, pause until you have your answers written, and then you may resume. Is this what you got? Some vocabulary. Opposites, also known as additive inverses. Two numbers that are the same division, which is 0 on the number line, but on opposite sides of the number line. For example, 2 and -2 are opposites, and -13 and 13 are opposites. Absolute value is the distance a number is from 0 on a number line. It will always be positive. The absolute value of -17 is 17 because it's only 17 spaces away from 0, regardless of which direction. Likewise, the absolute value of 17 is 17. Reciprocal known as multiplicative inverses. The reciprocal of any non-zero number is 1/a. This is because we flip the fraction upside down. A/1 becomes 1/a. So the reciprocal of 5 would be 1/5. The reciprocal of 3/5 would be 5/3. And the more challenging example, the reciprocal of -3.2 would be -5/16. You can write it as a fraction, -3.2/1, and flip it upside down, 1/-3.2. But since we're not allowed to have decimals within fractions, I can multiply the numerator and the denominator both by 10 to get 10/-32, and then reduce. Another option would be to read this out loud as -3 2/10, and write it as a fraction right away, which is -3 1/5 reduced. As an improper fraction, that would be -16/5, and then I could take the reciprocal to get my -5/16. Try to fill in this. I'll pause the screen and resume once you're finished. If the number then its opposite is -300, its absolute value is 300, and its reciprocal is 1/300. If your number is 5.5, the opposite is -5.5, the absolute value is 5.5, and the reciprocal is 2/11. If you have -0.001 or -1,000th, the opposite would be 1,000th. Your absolute value would be 1,000th, and your reciprocal would be -1,000. If you have 6 pi, the opposite is negative 6 pi, the absolute value is 6 pi, and your reciprocal is 1 over 6 pi. By each of the following expressions. Don't forget to simplify within the absolute value symbols first before taking the number. Pause the screen until you're ready. So we start with 5 minus negative 4, and then take the absolute value, which is positive 4. Inside the absolute values for number 2, negative 2 times 3 gives us negative 6. The absolute value is positive 6. Number 3, I take the absolute value of negative 2, and I'm multiplying since there's no operation in between. I'm sorry, this would be positive 2. So now I have 1.4 as my final answer. Absolute value of 3 is 3. Absolute value of negative 10 is 10. And I'm subtracting those answers to get negative 7. Now to review some. The commutative property of addition and the commutative property of multiplication states that you can move and that they'll still be equal. My hint is that the word commute means to move. So for the commutative property of addition, regardless of whether you write 5 plus 6 or 6 plus 5, you'll get the same answer, 11. There's no such thing as the commutative property of subtraction or the commutative property of division, only addition and multiplication. For the associative property of addition, notice how the move, 5, 6, 7. Instead, the only difference is which ones are grouped and where the parentheses are. So I like to remember this by thinking of the word associate as group, kind of like an association. Next is my hint is that identity is who you are, it doesn't change. And therefore, for the identity property with 5, I don't want to change it. I want to keep it as 5. So for the identity property of addition, the only number that I can add that won't change its value is 0. So any number plus 0 is that number. In the identity property of multiplication, the only number that I can multiply by so that I don't change the identity is 1. So 9 times 1 is 9. Any number times 1 is that number. Inverse properties. Inverse means opposite. So for example, if I take 5 plus its additive inverse, which is negative 5, 0. The sum of a number and its additive inverse or opposite is always 0. The inverse property of multiplication is when I take a number and multiply by its reciprocal or multiplicative inverse, which will always give me 1. Distributive property, I think of the word distribute. I'm distributing the factor to each addend. Note that for distributive property, I'm multiplying by a quantity in parentheses. In that quantity, there's always going to be either a plus or a minus sign, not multiplication or division. Here I distribute my 5 to the 3 and to the 11, so I can do 5 times 3 plus 5 times 11. This screen so you can try this on your own. Match each number with the property being illustrated. Number 1, 4 equals 0, is taking a number plus its additive inverse and having it equal 0. So this is the inverse property, G. Number 2, I'm moving the numbers around, negative 2 and 1. So that would be the commutative property of addition, A. Number 3, the only difference is that I'm multiplying by 1. So this would be the identity property of multiplication, F. For number 4, the only difference is when I add 0, which does not change the value of 8, and therefore it's the identity property of addition, E. Number 5, the only difference is that I switch the 2 and the 5, their order. Since I'm moving the numbers, this would be the commutative property of multiplication, B. In the next example, the numbers are in the same place, -5, 2, -3, -5, 2, -3. The only difference is the parentheses. Therefore, this is associative property of addition, C. And finally, number 7, the numbers again are in the same place. The only difference is the parentheses or grouping, so the answer is associative property of multiplication, D.